Hello, my dear students. So, in the last class, we have discussed regarding the preparation of some addition polymers. We have seen the examples of polythene, and under polythene, there are two types, that is, low density polyethylene and high density polyethylene, and important catalyst called as Ziegler-Natta catalyst. And also, we have seen the examples of addition polymers like polytetrafluoroethene, commonly called as a Teflon, and polyacrylonitrile pan, which is also commonly called as a Orlon. Now, these are the examples for your addition polymers. So, in the examination, he may ask directly write the preparation of any one type of addition polymerization or polymers, or directly he may ask write the preparation of LDP, HDP, or Teflon or Orlon directly, right? Now, these are all examples for addition polymers. Now, the second types of polymers which we are going to discuss with preparation is condensation polymers. So, in today's class, we'll begin with respect to preparation of some condensation polymers. So, we know that what do you mean by condensation polymers? So, these are the polymers in which two or more type of monomers react to give the polymers. Along with that, there is formation of the removal of small molecules like water, alcohol, ammonia, etc. That is with respect to condensation polymers. Now, under condensation polymers, there are different types of examples which we are going to study with preparation of polymers. And the first type polymer we are going to study with condensation polymer is called as polyamides. Now, as the name indicates, poly refers to many, amides, the amide group or the linkage. What do you mean by amide group or linkage? So here, the polymers which contain amide linkage, that is CONH group. If the polymer consists of CONH group, that linkage we call it as what? Amide linkage. In the chain are known as what? Polyamides. So I think the definition is very clear. So polyamides are nothing but the polymers which consist of the amide linkage such as CONH groups are called as polyamides. So example includes here nylon 6,6 and nylon 6. There are two different polymers here, dear students. Nylon 6,6 is one example and nylon 6 is one example. We are going to study the preparation of both these type of polymers. So these two come under the examples of what? Polyamides. Polyamides are examples for condensation polymers. So we'll study with the first type of polyamides polymer. So that is a nylon 6,6. Now by dear students, ಇದನ್ನ ಭಾಳ ಸಲ ಎಕ್ಸಾಮ್ ಕೇಳಿದ್ದಾರೆ ನೈಲಾನ್ 6,6 ಅನ್ನೋದು, ರೈಟ್. ಸೊ ಇದ್ರ ಇಂಪಾರ್ಟೆನ್ಸ್ ಏನು, ಇದು ಪ್ರಿಪ್ರೇಷನ್ ಹೆಂಗೆ ಅಂತಂದು ಸ್ಟಡಿ ಮಾಡಮಂತ, ರೈಟ್. ಸೊ ಇಟ್ ಈಸ್ ಇಂಪಾರ್ಟೆಂಟ್ ಎಕ್ಸಾಂಪಲ್ ಫ್ರಮ್ ಯುವರ್ ಎಕ್ಸಾಮ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಆಲ್ಸೋ. Now, nylon 6,6 is example for polyamide, right? So polyamide means which contains amide linkage, that is CONH group. Now, what is nylon 6,6? How it is obtained? We'll study here. So here the polymer nylon 6,6 is obtained by condensation of adipic acid and hexamethylene diamine with the elimination of water molecule. Notice students, it is all important too. The monomer of nylon 6,6 is what? Adipic acid and hexamethylene diamine. ಇವೆರಡು monomer react ಆದಾಗ ಏನು ಬರ್ತೈತಿ? Nylon 6,6. ಈಗ nylon 6,6 is example for condensation polymer. How do you say that? Because there is elimination of water molecule. If there is along with the formation of polymer, if there is elimination of small molecules like water or ammonia or alcohol, then we call it as what? Condensation polymers. So nylon 6,6 is obtained by the reaction with the monomers between adipic acid and hexamethylene diamine with the elimination of small water molecules. So here you can see the structure of formation of your nylon 6,6. Now this is adipic acid. What is adipic acid? N molecules of COOH, CH2 4 times COOH, right? So ಇದಕ್ಕೆ ಏನು ಕರಿತೀವಿ? Adipic acid ಅಂತ ಕರಿತೀವಿ. Along with hexamethylene diamine. What is hexamethylene diamine? Hexa refers to 6. So there are 6 CH2 groups and amine group and diamine ಅಂತಂದ್ರೆ amine ಅಂದ್ರೆ NH2 NH2. So N molecules of hexamethylene diamine reacts with N molecules of adipic acid. So ಇಲ್ಲಿ how the monomers react to form a polymer ಅಂತಂದ್ರೆ ಇಲ್ಲಿ as I had told here, there is elimination of water molecule. So here you can see there is a OH group present over here and one of the hydrogen of NH2, it reacts with this OH to form what? H2O. So ಇಲ್ಲಿ H2O ಬಂತು, ಇದರೊಳಗಿಂದ OH ಹೋಯ್ತು, ಇದರೊಳಗಿಂದ hydrogen ಹೋಯ್ತು. So these are eliminated in the form of what? Water. Now what is left out? CO and ಇಲ್ಲಿ NH ಒಳಗಿಂದ ಒಂದು ಹೈಡ್ರೋಜನ್ ಹೋಯ್ತಂದ್ರೆ NH ಉಳಿಯುತ್ತೆ. ಸೊ CO and NH they are linked with each other here. CO NH groups are linked here. So it results into formation of what? A polyamide linkage, that is nothing but CONH group. So hence it results into formation of what? The nylon 6,6. So ಇಲ್ಲಿ ಕೂಡ ಸೇಮ್ ಅದ, ಇಲ್ಲಿ OH ಗ್ರೂಪ್ ಅದ. ಸೊ ಇಲ್ಲಿ ಕಂಟಿನ್ಯೂಷನ್ ಇಲ್ಲಿ H2 NH2 ಬಂತಂದ್ರೆ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಇದು OH ರಿಯಾಕ್ಟ್ ಆಗಿ H2 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ CO ಗ್ರೂಪ್ ಆಸ್ ಯೂಶುವಲ್ ಇರ್ತದೆ, ಇಲ್ಲಿ NH ಗ್ರೂಪ್ ರಿಯಾಕ್ಟ್ ಆಗ್ತದೆ, ಇಲ್ಲಿ ಕಂಟಿನ್ಯೂಷನ್ ಆಗ್ತದೆ NH ಅದ ಇಲ್ಲಿ. ಸೊ ಅಗೇನ್ ಒಂದು ಹೈಡ್ರೋಜನ್ ಇದ್ರೊಳಗಿಂದ ಹೋಯ್ತಂದ್ರೆ NH ಉಳಿದ್ಬಿಡ್ತೈತಿ. ಸೊ ಇಟ್ ರಿಸಲ್ಟ್ಸ್ ಇನ್ ಟು ಫಾರ್ಮೇಶನ್ ಆಫ್ ದ polymer called as what? Nylon 6,6. Very important and very easy type of reactions ಇದು. Adipic acid and hexamethylene diamines are the monomers. ಎಕ್ಸಾಮ್ ಒಳಗೆ ಕೇಳ್ತಾರೆ, ನೇಮ್ ದ monomers of nylon 6,6 polymer ಅಂತ ಕೇಳ್ತಾರೆ. ಸೊ 1 ಮಾರ್ಕ್ಸಿಗೆ ಅಂತ ಕೇಳಿದಾಗ monomers are nothing but what? Adipic acid and hexamethylene diamine. ಸೊ ಇವೆರಡು ರಿಯಾಕ್ಟ್ ಆಗಿ ನಮಗೆ nylon 6,6 ಬರ್ತಾವ. ಮತ್ತು ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಒಳಗೆ ವಾಟ್ ಟೈಪ್ ಆಫ್ linkage are present in case of nylon 6,6 ಅಂತ ಕೇಳಿದಾಗ it is amide linkage, CONH linkage ಅಂತ ಕೇಳ್ತಾರೆ, right? So it is an example for polyamide. So I think you understood with the example of nylon 6,6. Now ಕೆಲವೊಬ್ರು ಕ್ವಶನ್ ಕೇಳ್ತಿರ್ಬೋದು, ಈಗ ಸರ್ ಎದಕ್ಕಿದು 6,6 ಅಂತ ಕರೀತಾರ, ಎದಕ್ಕಿದಕ್ಕೆ ವಾಟ್ ಇಸ್ ದ ಸ್ಪೆಷಲೈಸೇಷನ್ ಆಫ್ ಕಾಲಿಂಗ್ ದಿಸ್ ಆಸ್ 6,6, that we are going to study now. So the polyamides are identified by the numbers. These numbers refer to the number of carbon atoms in diamine and in the dibasic acid. So as in the above case, the carbon atoms are 6 in each case. Therefore, the product is described as nylon 6,6. So ಅಂದ್ರೆ ಅರ್ಥ ಏನ್ರಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಅಂದ್ರೆ, ಇಲ್ಲಿ ಅಡಿಪಿಕ್ ಆಸಿಡ್ ಒಳಗೆ ನೋಡ್ರಿ ಎಷ್ಟು ಕಾರ್ಬನ್ ಅವ ಇಲ್ಲಿ, E4 belongs to this carbon. So totally 4 carbon here, 1 carbon here, 1 carbon here. So totally how many carbons of adipic acid? 6. Similarly in hexamethylene diamine ಒಳಗೂ ಎಷ್ಟು ಕಾರ್ಬನ್ ನೋಡ್ರಿ 6 ಅವ, ಇಲ್ಲಿ NH2 ಅದ, ಇಲ್ಲಿ NH2 ಅದ, ನೋ ಕಾರ್ಬನ್ ಹಿಯರ್. ಸೊ ಡೈರೆಕ್ಟ್ಲಿ ಇಲ್ಲೂ ಕೂಡ 6. ಸೊ 6 carbons of adipic acid and 6 carbons of hexamethylene diamine. So hence it is commonly called as what? 6,6. So it is very clear, I suppose, right? So 6,6 edakantandre the number of carbon atoms in each monomers are 6. So there are two monomers here, that is adipic acid and hexamethylene diamine. So hence it is called as what? Nylon 6,6. So it is very clear, I suppose, right? Okay, so we'll see some of the properties and uses of nylon 6,6. Nylon 6,6 is a linear polymer and has a very high tensile strength. So tensile strength high is the, it shows a good resistance to abrasion, right? So it is a good resistance for abrasion, right? So these are some properties with, and also uses ಅಂತ ನೋಡಿದಾಗ it is usually fabricated into sheets ಆಗಿ ಟರ್ನ್ ಮಾಡ್ತಾರೆ. It is used in bristles for brushes and in textile ಅನ್ನು ಯೂಸ್ ಇಂಡಸ್ಟ್ರೀಸ್ ಒಳಗೆ ಯೂಸ್ ಮಾಡ್ತಾರೆ. So these are some of the uses related to that of your nylon 6,6. So ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್ type of example for your examination. So nylon 6,6 is an example for polyamide. Polyamide ಒಳಗ ಯಾವ type of polymer ಇದು? Condensation polymer, right? So ಇದೊಂದು ಸ್ವಲ್ಪ ನೆನಪಿಟ್ಕೊರಿ, right? Then we go for second type of polyamide called as nylon 6, right? So nylon 6 is obtained by heating caprolactam with water at a high temperature. So the monomer which is present in the formation of the polymer nylon 6 is caprolactam. So caprolactam ಇದು polymer monomer ಇದ್ದು polymerization ಆದಾಗ we obtain what? Nylon 6, right? So here ನೋಡ್ರಿ, this is the structure for caprolactam: NH CH2 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 CH2. So you can write NH CH2 ಎಷ್ಟು ಇಲ್ಲಿ 5. So NH CH2 5 times CO. This is the structure for your caprolactam. So when it is heated for about 533 to 543 Kelvin in presence of water, we can obtain what? Nylon 6. So ಇಲ್ಲಿ ಕೂಡ ನೋಡಬಹುದು ನೀವು, ಇಲ್ಲಿ CH2 5 times ಐತಿ plus 1 carbon. So totally how many carbons are involved here? 6 carbons. So hence it is called as what? Nylon 6. So ಇದು polymer ಆಗಿ it forms a polymer called as nylon 6. So nylon 6 ಒಳಗೆ monomer unit ಯಾವುದು? Caprolactam. What is the formula of caprolactam? NH CH2 5 times CO. So this is the formula for your caprolactam. Nylon 6,6 ಒಳಗ ಯಾವುದು monomers? Adipic acid as well as hexamethylene diamine. So confuse ಆಗಬೇಡ್ರಿ nylon 6 ಮತ್ತೆ nylon 6,6. Now second type of condensation polymer we are going to discuss is polyester. ನೋಡ್ರಿ polyamides ಒಳಗ ಎರಡು ಎಕ್ಸಾಂಪಲ್, ಒನ್ ಈಸ್ nylon 6,6, ಇನ್ನೊಂದು nylon 6. ಅದ್ರೊಳಗೆ ಏನಿರ್ತದೆ ಕಾಮನ್ ಆಗಿ ವಾಟ್ ಟೈಪ್ ಆಫ್ ಲಿಂಕೇಜ್ ಅಂದ್ರೆ CONH group, that is amide linkage ಇರ್ತದೆ. We are going to study now with respect to second type of condensation polymer called as what? Polyester. So ಇದ್ರೊಳಗ ಹೆಸರು ಆಲ್ರೆಡಿ ಹೇಳಿದಾರ, the type of linkage present here is ester. So what is ester linkage? COOR group is called as what? Ester group, and the linkage is called as ester linkage. So these are the polymers containing the ester linkage, that is COOR, right? They are obtained by polymerization of dicarboxylic acids with diols. Now study madam ante dicarboxylic acids example with the diols olaga, right? So polyesters olaga, these are the polymers which contain the ester linkages, right? So ಇದಕ್ಕೆ ಯಾವ examples ಅಂತ ಅಂದಾಗ ಮೊದಲನೇದು ಟರ್ಲೀನ್ ಆರ್ ಡೆಕ್ರಾನ್, ಕಾಮನ್ಲಿ ಕಾಲ್ಡ್ as ಡೆಕ್ರಾನ್. ಸೊ ಈ ಎಕ್ಸಾಂಪಲ್ಸ್ ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಎಡಿಷನ್ ಅಂಡ್ ಕಂಡೆನ್ಸೇಷನ್ ಪಾಲಿಮರ್ಸ್ ಒಳಗೆ ಯಾವ್ದೋ ಒಂದು ಕ್ವಶನ್ ಕಂಪಲ್ಸರಿ ಕೇಳ್ತಾರ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದ ಸ್ಟ್ರಕ್ಚರ್ ಕೇಳ್ತಾರ, monomers ಕೇಳ್ತಾರ. ಸೊ ಬಿ ಪರ್ಫೆಕ್ಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು each examples, right? So terline or decron is an example for what type of condensation polymer? It is example for polyester linkage or polyester polymer, right? So either what terline or decron again here the you'll know ragle one here the sentence. So these are obtained by polymerization of dicarboxylic acid. So dicarboxylic acid is andre there is presence of two COH groups with diols. Diols andre ಎರಡು OH groups ಇರ್ತಾವ. ಸೊ ಇವೆರಡು ರಿಯಾಕ್ಟ್ ಆದಾಗ we obtain what? Polyester polymers, right? So you'll note the example ಒಳಗ here for terline or decron the monomers used is terphthalic acid and ethylene glycol. So you'll ನೋಡಬಹುದು terphthalic acid ಒಳಗ there is presence of two COOH group, right? So ಅದಕ್ಕೆ dicarboxylic acid, right? With diols ಅಂತಂದ್ರೆ diols ಅಂದ್ರೆ ಏನು? There is presence of two OH groups. So ethylene glycol formula CH2OH, CH2OH. This is the formula for your ethylene glycol. So when ethylene glycol is made to react with terphthalic acid, it forms the polymer called as what? Decron or terline. ಹೆಂಗ್ ಇದು ರಿಯಾಕ್ಷನ್ ಆಗ್ತೈತ್ರಿ? ಇಲ್ಲಿ ನೋಡ್ರಿ ಸಿಂಪಲ್ ಅದ. ಇದ್ರೊಳಗ ಕೂಡ ಇಟ್ ಇಸ್ ಎ ಕಂಡೆನ್ಸೇಷನ್ ಪಾಲಿಮರ್. ಇಲ್ಲಿ ಕೂಡ there is removal of water molecule. So ಇಲ್ಲಿ OH group ಅದ, right? Idrogin one hydrogen. If there is removal of OH and hydrogen as water, so this CO links with CH2O, right? So CH2O E group ಮತ್ತೆ CO group link ಆಗಿ it forms a polymer. So hence this is an example for your terline or decron. So along with what? There is minus H2O ಇಲ್ಲಿ, there is removal of water molecule. So hence terline or decron is formed by the monomers called as what? Terphthalic acid with ethylene glycol. So terphthalic acid it is a dicarboxylic acid, ethylene glycol is a diol, right? So it results into formation of decron or terline. These structures important students, so ಸ್ವಲ್ಪ perfect agree. Now we are what are the properties and uses of terline or decron? So this decron or terline is high resistance to action of chemicals. So chemicals ಜೊತೆ ಭಾಳ ರೆಸಿಸ್ಟ್ ಆಗ್ತದೆ, ಜಲ್ದಿ ರಿಯಾಕ್ಟ್ ಆಗಂಗಿಲ್ಲ, right? It is very strong, right? So highly resistance to action of chemicals. It is strong, flexible and durable. So easy terms of you, right? Strong ada, flexible ada, durable ada, ಬಾಳಕೆ ಬರ್ತದೆ ಬಹಳ. It is used in blending with cotton, mixing with cotton, wool fibers. So right, it is used in manufacture of tire cords or fabrics or seat belts. Seat belts ತಯಾರು ಮಾಡೋದ್ರೊಳಗ we use what? Terline or decron. So these are some of the properties and uses related to that of the polymer called as terline or decron. Terline or decron is an example for what type of condensation polymer? It is example for polyester, right? Then we go for the second type of polyester examples called as phenol formaldehyde polymer, right? So phenol formaldehyde polymer which is commonly called as what? Bakelite. ಇದು ಭಾಳ ಇಂಪಾರ್ಟೆಂಟ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಒಳಗೂ ಕೇಳಿದ್ದಾರೆ, ರೈಟ್? ಸೊ ಇದ್ರ ಹೆಸರು ಒಳಗೆ ನಿಮಗೆ ಆನ್ಸರ್ ಸಿಕ್ಕಿದ. ಇದ್ರೊಳಗಿರುವಂಥ ಮೊನೋಮರ್ಸ್ ಯಾವುದು? ಪಾಲಿಮರ್ಸ್ ಒಳಗೆ there is a reaction between phenol and formaldehyde. These together forms what? Phenol formaldehyde polymer which is commonly called as what? Bakelite. So these polymers are obtained by the condensation reaction with the phenol with the formaldehyde in the presence of either acid or base catalyst. So phenol and formaldehyde they react. These are the monomers to form bakelite, that is a polymer. The reaction involves the formation of methylene bridge at ortho para or both ortho and para positions. So study ಮಾಡೋ structure ಇದೆ right? So it is important to the reaction involves formation of methylene group. Methylene group ಅಂದ್ರೆ CH2 groups, ಎರಡು compounds ನಡುವೆ bridge ಆಗಿರ್ತದೆ either at the ortho position or para position or both ortho and para position. So here you can see here this is the structure of your bakelite. ಸ್ವಲ್ಪ structure complicated ಅನ್ಸ್ಬೋದು but it is very easy. Now as I told, the monomer in bakelite is what? Phenol and formaldehyde. What is formaldehyde? HCHO. So phenol is C6H5OH. So here it undergoes in presence of an acid or base catalyst. So base is OH minus. So it forms what? First ortho hydroxy methyl phenol. So this is ortho position, right? So ortho hydroxy methyl phenol along with the formation of the byproduct. So this undergoes condensation, right? So polymerization ಆಗ್ತದ. So hence it results into formation of copolymerization ಆಗಿ ಇಲ್ಲಿ linkage between the two molecules methylene group ಆಗಲೇ ಹೇಳಿದೆ ಇಲ್ಲಿ. There is a reaction involves the formation of methylene bridges. So methylene bridges is nothing but CH2. ಎರಡು ನಡುವೆ CH2 groups is linked either towards the ortho position or para position or ortho and para position. So this is the structure for your Becquerelite. ಇಲ್ಲಿ ಒಂದು ಸ್ಕ್ವೇರ್ ಬ್ರಾಕೆಟ್ ಹಾಕಿ ಎರಡು ಕಡೆ, so right. So Becquerelite structure ಕೇಳಿದಾಗ this is the structure for Becquerelite. So ಇದೆಲ್ಲ reaction ಬರೆದಾಗ it indicates what the formation of Becquerelite or phenol formaldehyde polymer. So here methylene groups are joined together between the two groups, or it is a bridge between the two groups, right? So hence it forms what the Becquerelite or phenol formaldehyde polymer. Now, what are the uses of this bakelite? Bakelite is used for making combs, photograph records, electrical switches, etc. Then soft bakelites with low degree of polymerization are used as a binding glue. Glue ಅಂದ್ರೆ gum ಅಂತ ಅರ್ಥ, for laminated wooden planks in varnishes and lacquers, right? So varnishes ಅಂದ್ರೆ paints, right? So ಅಲ್ಲಿ use ಮಾಡ್ತೀವಿ bakelite due to what soft low degree of polymerization ಇರೋದ್ರಿಂದ, right? So these are some of the uses of bakelite, right? Important polymer of polyester. Then the third and last type of example for polyester is a melamine formaldehyde resin, right? So is here ಇದ್ರೊಳಗೆ ಹೆಸರು ಒಳಗೆ ಯಾವ್ದು ಇದ್ರೊಳಗೆ ಪಾಲಿಮರ್ ಒಳಗೆ ಮೊನೋಮರ್ ಯಾವುದು melamine ಮತ್ತೆ formaldehyde. So it is a copolymer formed by the polymerization of melamine, which is a heterocyclic triamine and formaldehyde. So ಇದ್ರೊಳಗೆ ಮೊನೋಮರ್ ಹೇಳ್ದಂಗೆ melamine is nothing but a heterocyclic triamine and formaldehyde. So ಹೆಂಗಾಗ್ತದೆ ರಿಯಾಕ್ಷನ್ ನೋಡೋಮಂತ. ಸೊ ಇಲ್ಲಿ ನೋಡ್ಬೋದು, ಇಲ್ಲಿ ಮೆಲಮೈನ್ ಐತಿ, ಸೊ ಟ್ರೈಅಮೈನ್ ಐತಿ, ರೈಟ್? ಹೆಟ್ರೋಸೈಕ್ಲಿಕ್ ಟ್ರೈಅಮೈನ್ ಐತಿ. ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಅಂತ ಫಾರ್ಮುಲಾ ಬರ್ತದೆ HCHO. ಸೊ ಇಟ್ ರಿಸಲ್ಟ್ಸ್ ಇಂಟು ಫಾರ್ಮೇಷನ್ ಆಫ್ ದ ಸ್ಟ್ರಕ್ಚರ್. ಎಲ್ಲದರೂ ಕಾಮನ್ ಆದ ದರ್ ಇಸ್ ರಿಮೂವಲ್ ಆಫ್ ವಾಟರ್ ಮಾಲಿಕ್ಯೂಲ್ ಹಿಯರ್, ರೈಟ್? ಸೊ ಇಟ್ ರಿಸಲ್ಟ್ಸ್ ಇಂಟು ಫಾರ್ಮೇಷನ್ ಆಫ್ copolymer or polymers called as melamine formaldehyde polymer, right? So ಇಲ್ಲಿ ಈಸಿ ಒಂದು ಸ್ವಲ್ಪ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಸ್ವಲ್ಪ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು, so that it becomes easy for you, right? In all these type of reactions it is a condensation polymer, so hence there is removal of what water molecules, right? So hence it results into formation of monomers into polymers, right? Now what are the uses of this properties and uses of melamine formaldehyde polymer andre, it is very hard, it is tough, and they do not break even when dropped from a height. So ಮ್ಯಾಲಿಂದ ಬಿಸಾಕಿದ್ರು ಕೂಡ ಇವು ಬ್ರೇಕ್ ಆಗಂಗಿಲ್ಲ. ಸೊ ಅದು ಒನ್ ಆಫ್ ದ ಪ್ರಾಪರ್ಟಿ ಮತ್ತೆ ಯೂಸ್ ಕೂಡ. ಸೊ ದೇ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ಡ್ ಇನ್ ಎನಿ, ಈ ಪ್ರಾಪರ್ಟಿನ ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು, ರೈಟ್? ಸೊ ದಟ್ ಈಸ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು melamine formaldehyde polymer. Then we go for the next concept, we call it as a rubber, right? So rubber ಬಗ್ಗೆ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ಇಲ್ಲಿ, based upon the molecular forces ಒಳಗ 4 types elastomers, right? Fibers, right? Thermoplastic and thermosettings ಒಳಗ. ಸೊ ಅದರ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ ರಬ್ಬರ್ ಅಂತಂದು. ಸೊ ಇಟ್ ಈಸ್ ಎನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಎಲಾಸ್ಟೋಮರ್, ರೈಟ್? ರಬ್ಬರ್ ಅಂತೂ ಎಲಾಸ್ಟಿಕ್ ಇದ್ದಂಗೆ ಇರ್ತದ, ವಿ ನೋ ದಟ್, ರೈಟ್? ದಿಸ್ ಈಸ್ ಹ್ಯಾವಿಂಗ್ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಎಲಾಸ್ಟೋಮರ್ಸ್. Now these are natural rubbers are of, these are their rubbers are of two types. One is called as natural rubber, second one is called as synthetic rubber. So ಹೆಸರೊಳಗದ the rubber which is obtained in nature or naturally is called as natural rubber, and the rubber which is prepared or man-made rubbers are called as what? Synthetic rubber. So first we are going to study here with respect to natural rubber. ಸೊ ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ ಅಂತಂದ್ರೆ ಇಟ್ ಇಸ್ ಅ ಪಾಲಿಮರ್ obtained ಆಗ್ಬೇಕಾಯ್ತು, ಇಲ್ಲಿ obtain ಅಷ್ಟೇ ಐತೆ. ಇಟ್ ಇಸ್ obtained ಫ್ರಮ್ ರಬ್ಬರ್ ಲ್ಯಾಟೆಕ್ಸ್ ವಿಚ್ ಈಸ್ ಎ ಮಿಲ್ಕಿ ಸ್ಯಾಪ್ obtained ಫ್ರಮ್ ರಬ್ಬರ್ ಟ್ರೀಸ್. ಸೊ ನಿಮ್ಗೆ ಗೊತ್ತದ, ಗಿಡ ಇರ್ತದ, ಗಿಡದಾಗಿಂದ ಹಾಲು ತೊಗೊಂಡು ವಿ ಪ್ರಿಪೇರ್ ದ ರಬ್ಬರ್, ರೈಟ್? ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಲ್ಯಾಟೆಕ್ಸ್, ರಬ್ಬರ್ ಲ್ಯಾಟೆಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ ಅದಕ್ಕೆ. ಈ ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ ಒಳಗೆ ಏನದ, ವಾಟ್ ಈಸ್ ದ ಕೆಮಿಕಲ್ ಕಾಂಪೌಂಡ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಹಿಯರ್ ಈಸ್, it is a linear polymer of isoprene. So natural rubber consists of the monomer called as what? Isoprene. So isoprene ಅಂದ್ರೆ ಏನು? 2 methyl 1,3 butadiene. This is a isoprene, right? So ಇದಕ್ಕೆ ಸ್ಟ್ರಕ್ಚರ್ ಯಾವ್ದು? So natural rubber is made up of what? 2 methyl 1,3 butadiene. Now this natural rubber is a cis isomer. So cis isomer ಅಂದ್ರೆ ನಿಮ್ಗೆ ಗೊತ್ತದ, ಆಲ್ರೆಡಿ ಫಸ್ಟ್ ಇಯರ್ ಸ್ಟಡಿ ಮಾಡಿರಿ, cis form ಮತ್ತೆ transform ಅಂತಂದು. Natural rubber is just example for cis isomer, hence it is called as what? Cis 1,4 polyisoprene. So isoprene units ಏನಾಗ್ತಾವ? This is a monomer. ಈ ಮೊನೋಮರ್ ರಿಯಾಕ್ಟ್ ಆಗಿ ಪಾಲಿಮರ್ ಆಗ್ತದೆ. ಸೊ ಆ ಪಾಲಿಮರ್ ಇಟ್ ರಿಸಲ್ಟ್ಸ್ ಇನ್ ದ ಫಾರ್ಮೇಷನ್ ಆಫ್ ವಾಟ್? ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್. ಸೊ ನೇಮ್ ದ ಮೊನೋಮರ್ ಆಫ್ ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ ಅಂತಂದ್ರೆ ಐಸೋಪ್ರೀನ್ ಅನ್ಬೋದು, ಅಥವಾ 6 1, ಇದು ಇಸ್ ಅ ಪಾಲಿಮರ್. ಸೊ ಐಸೋಪ್ರೀನ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಮೊನೋಮರ್ ಆಫ್ ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ ವಿಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ 2-methyl 1,3 butadiene. So you can see the structure here. I'll tell you the structure here, right? So natural rubbers contains various chains of cis 1,4 polyisoprene which are held together by weak van der Waals forces. ನೋಡ್ರಿ ಎಲಾಸ್ಟಿಕ್ ಪ್ರಾಪರ್ಟಿ ಅಥವಾ ಹೇಳ್ಬೇಕಾದ್ರೆ ನಾನು ಆಲ್ರೆಡಿ ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಆಗ ಅಲ್ಲಿ ಹೇಳಿದೆ these elasticity is due to presence of weak van der Waals force of attraction ಅಥವಾ weak intermolecular force of attraction, right? So hence it is elastic and non-crystalline in nature, and it is used in making shoes and waterproof coats. So it uses ಆಗ್ತದ. So natural rubbers are used in making shoes and waterproof coats. So here you can see the structure of your natural rubber. So natural rubber is made up of isoprene units in which carbon 1 and carbon 4 are joined together. So ಇಲ್ಲಿ ಹೆಸರು ತಗೊಂಡಾಗ what is the name of this compound isoprene? 2-methyl 1,3 butadiene. So ಇಲ್ಲಿ ನೋಡ್ರಿ 1 2 2 methyl, so there is presence of methyl group at the second carbon. 1 comma 3, so first carbon and third carbon are joined together by there is presence of a double bond. So 1 comma 3 butadiene edakandre there is presence of 1 2 3 and 4 carbons. So hence they are joined together here. It results into formation of what? The natural rubber. So natural rubber is made up of the monomer called as what? Isoprene. Isoprene is nothing but the 2-methyl 1 comma 3 butadiene, right? So this is with respect to the natural rubber. Then we go for one of the important concept with natural rubber called as vulcanization of rubber. ಇದು ಬಹಳ ಇಂಪಾರ್ಟೆಂಟ್. ಒನ್ ಮಾರ್ಕ್ಸ್ ಕೇಳ್ತಾರ ವಾಟ್ ಈಸ್ ವಲ್ಕನೈಸೇಷನ್ ಆಫ್ ರಬ್ಬರ್ ಅಂತಂದು. ಸೊ vulcanization of rubber ಅಂದ್ರೆ ಏನಂತಂದ್ರೆ the natural rubber becomes very soft at 60 degrees Celsius. 60 degrees Celsius heat ಮಾಡಿದಾಗ very soft ಆಗುತ್ತೆ. So in order to get strength and elasticity of natural rubber is vulcanized. So ಏನ್ ಮಾಡ್ತೀವಿ ಇಲ್ಲಿ ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ನ ಎಲಾಸ್ಟಿಸಿಟಿ ಮತ್ತು ಸ್ಟ್ರೆಂತ್ ನ ಇಂಪ್ರೂವ್ ಮಾಡತ್ತೀವಿ. ಹೆಂಗ್ ಇಂಪ್ರೂವ್ ಮಾಡ್ತೀವಿ ಅಂತಂದ್ರೆ the natural rubbers are heated with sulfur or compounds of sulfur to 100 degrees Celsius to give its greater elasticity and ductility to the rubber. So this process is called as what? Vulcanization of rubber. So very important definition for 1 marks. So vulcanization of rubber andre ಏನಂತಂದ್ರೆ if the natural rubber is heated with sulfur or compounds of sulfur to 100 degrees Celsius, it results into increase in the elasticity and the ductility property of the rubber. So that process we call it as what? Vulcanization of rubber. So 1 marks ಗೆ ಬಹಳ ಸಲ ಕೇಳಾರೆ ಇದನ್ನ. Define vulcanization of rubber ಅಥವಾ name the compound which is added during vulcanization of rubber ಅಂತಂದ್ರೆ sulfur or compounds of sulfur are added to increase the elasticity and ductility. So questions na ಹೆಂಗೆ ಕೇಳಿದ್ರೆ when sulfur or sulfur compounds are added to vulcanization process what property changes ಅಂತ ಕೇಳ್ತಾರ. So here the property which is changing is it increases its elasticity and ductility, right? So you add ಮಾಡೋದ್ರಿಂದ elasticity ಮತ್ತು ductility property increase ಆಗುತ್ತಾ ಯಾವುದು ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ಗೆ. ಆ process ಗೆ ಏನೇನು ಕರಿತೀವಿ? Vulcanization of rubber. So very important for 1 marks, right? Now sulfur, what happens during this reaction? ಏನಾಗ್ತದೆ ಸಲ್ಫರ್ ಕಾಂಪೌಂಡ್ಸ್ ಆಡ್ ಮಾಡಿದ ತಕ್ಷಣ ನ್ಯಾಚುರಲ್ ರಬ್ಬರ್ಗೆ ಅಂತಂದ್ರೆ sulfur compound reacts with the polymer molecules forming cross linked network. So ಈ sulfur add ಮಾಡೋದ್ರಿಂದ there is a cross linkage between the compound, right, or a polymer, right? So this cross linkage gives strength to the rubber. So hence vulcanized rubber is used in the manufacturing of rubber bands, the belts, the car tires. So this vulcanization of rubber results into the uses like it is used in preparation of rubber bands, belts and car tires. So sulfur compound add ಮಾಡೋದ್ರಿಂದ cross linkage between the polymer ಆಗ್ತತಿ. ಅದರಿಂದ ಏನಾಗ್ತತಿ it increases the mechanical strength, right? So this is very important concept, my dear students. So vulcanization of rubber for 1 marks is asked for many times. So hence be perfect with respect to this, right? So with this we'll end up with respect to today's class. So I revise what we have discussed up till now. So in today's class we have discussed with respect to the condensation polymers. So condensation polymers are nothing but the polymers which are formed with elimination of small molecules like water, alcohol, ammonia, etc. Under condensation polymers, we have studied with preparation of some of the polyamides, some of the polyesters. So under polyamides, two important examples, that is nylon 6,6 and second example nylon 6. These are, what is the common thing between these? These contain amide linkage, that is CONH group. Then with the second type of condensation polymer, we have seen polyester. It consists of an ester linkage, that is COOR linkage. So examples for polyesters include The first one terline or decron, second one for phenol formaldehyde polymer called as bakelite, third one melamine formaldehyde polymers. Then we have studied with respect to the rubber. Under rubber, first one we have discussed with natural rubber. The monomer present in the natural rubber is isoprene, which is nothing but 2-methyl 1,3 butadiene. Then we have seen the vulcanization of rubber. Then in the next class, I'm going to discuss with respect to the second type of rubber called as synthetic rubber. So, dear students, please, if you have any doubts, please message me or contact me, right, so that I can give you the concept clearance. So please go through the videos again and again, right, so it will be helpful for you. So from competitive exam point of view also, this chapter is very important, right? So with this, I'll be ending up today's session. So in the next class, we are going to study with respect to the synthetic rubber. So if you have any doubts, please go through the videos and please contact me. Okay, so thank you very much.